Okay, now what I'd like to do is to think about a different sort of component of a lot of these interacting processes, more the social component. So this is a photograph of a group called that we call Mr. Rick, and Mr. Rick stands for the Missouri River Recovery Implementation Committee. There's 70 representatives on this body, and it was formed as a requirement of the 2003 biological opinion to sort of try and get stakeholder input into the decision making on the Missouri River. Now, they have a consensus requirement. Their charge is to make recommendations to the Army Corps of Engineers on the management of the Missouri River system. However, they have a consensus requirement, which means that every single one of those 70 representatives from different groups, from groups as widely distributed as the tugboat captains on the Missouri River to the Nature Conservancy, every single one of those representatives has a veto over any recommendation. Not only do they have a veto, but they have to be able to vote and agree 2 meetings in a row before they can actually make a recommendation. And they only meet twice a year. So the speed with which they process information and make recommendations is very, very slow. And all of this was by design. This was all worked out through a very complex facilitation process. And so it's, a lot of people have high hopes for what Mr. Rick is going to provide in the process. I'm not so sanguine about the potential, the value that it might bring to the process. Not to say that I don't think stakeholder input is important. I'm just not sure that this represents a really meaningful way to get it into these kinds of decision-making processes. What I want to think about, though, is what are the consequences of this, or how, what are the consequences of this for future outcomes in the system? In other words, is the output of Mr. Rick known? And I would say no. I think this is another source of indeterminism in these systems. And so this fellow here, Walter Lippmann, was a political scientist who wrote back in the early part of the 20th century. And he wrote, the will of the people was a highly variable and incalculable factor at the point where knowledge is to be applied to action. Incalculable. In other words, not subject to things that we would be able to predict what the will of the people would be. Okay, when they actually came to choose something. Now, in the light of Matter's talk earlier today about or yesterday actually, about how ecology was regarded as an incalculable science in the 1950s, and now here we are calculating things, and not only that, but Matter was calculating the dynamics of human perspectives on these things. So, maybe there's hope. But at the moment, I would say we're still in the pickle where Lippmann was right about things like Mr. Rick. So what are the features of this sort of social indeterminism? I'm going to, I think it is non-stationary in the sense that if you look back over what has already occurred in the past, it's not going to be much guidance for you about what will happen in the future. And that is because people's values are constantly changing and, in fact, reacting against each other and against what's happening in the states of nature. And so you really, it's very difficult to use what's happened in the past as a guide to what will happen in the future. Not impossible, but difficult. It's irreducible in the same sense that the variation in the hydrograph is irreducible. You're not going to be able to make this stuff go away by studying the system. Okay, increased knowledge about those people and about the system itself is not going to make this variable outcomes from this kind of process go away. And it's non-probabilistic, which sort of goes along with the other two in the sense that describing this with a probability distribution is not likely to work. So now we've got sort of another way of thinking about indeterminism, not just aleatory and epistemic and linguistic and estimation error and those things, structural uncertainty. But we've got another sort of dimension, which is sort of natural and physical processes on the one hand, weather, population dynamics of species, non-human behavior, and on the other hand, social processes that arise, when we're talking about group decision making, and the sort of then shifts in values and changes in human behavior are causing sorts of problems with that. So we've got natural and physical processes on one hand, social processes on the other. And so what Sarah and I did was sort of thinking about how to put these things together was, well, you could sort of think about these as two independent axes on which you could plot any particular context that you happen to find yourself in. So here we've got natural indeterminism ranging from low to high, and it doesn't go to zero because a lot of this stuff is irreducible, right? You're not going to get rid of it at all. But it can be relatively low versus relatively high. And similarly, we have on this axis social indeterminism, where we go from relatively low to relatively high. And what I want to do is sort of illustrate the corners of this matrix with some examples. And we're going to start with the example that's already been raised in this conference a few times about the mid-continental mallard population. And we put this in the relatively low natural indeterminism and relatively low social indeterminism. Why do we do that? Well, so mid-continental mallards, among other waterfowl species, have been surveyed annually for over 60 years. Huge, tremendous amounts of scientific work. We know a lot about ducks, okay? Tremendous amount about ducks. And moreover, so that's on the natural side of things. It's not irreducible. We don't have a perfect prediction of how many ducks there will be, but we have a pretty good understanding of what's important for ducks. And then on the social side, decisions about annual harvest recommendations have been made with very little public turbulence, I'm going to use that term, for decades. Okay, so it's not like there's no controversy about what they should be or what they shouldn't be and things like that. But there's not a lot of using the courts and other sorts of social, there are relatively well worked out fora where people engage in discussions about what should be done. And this has gone on for decades and is likely to continue well. And so the fact that this notion that there's little turbulence, Kylie used the term turbulence, management turbulence for what I'm calling social indeterminism. And I kind of like the image of turbulence because if you, by analogy with physical turbulence in flow, we can predict the onset of physical turbulence, but we can't predict the actual detailed outcomes of turbulence. And so it's kind of a nice image. So what I want to do now is sort of slide up the social indeterminism scale to high levels of social indeterminism. And I would say that gray wolves are sort of in a similar state in terms of natural indeterminism, okay, to mallards. So it's not like we know exactly how many wolves there are out there, or exactly how many there will be next year, or how many cows they're going to eat, but we know a lot about wolves. I mean, there is a small army of biologists swarming across the northern Rocky Mountains, practically every wolf that's been released, or every wolf that's even been born in the greater Yellowstone ecosystem has a name. We know who its parents are. We know who its offspring are. We know where they live, who they hang out with, all of this stuff about them. Tremendous amount of information. And there's still things to be worked out scientifically. Okay, it's not like there's nothing to resolve yet. Okay, but by and large, we know a lot about wolves. And so recently, there have been a lot of discussions over whether or not wolves needed to be on the endangered species list. And so, in fact, a colleague of mine, Mike Runge from the U.S. Geological Survey, was part of a process, that they did some structured decision making and they looked at some of these kinds of processes. And subsequent to that, although not necessarily directly derived from that, the Fish and Wildlife Service decided to delist the northern Rocky Mountain gray wolf population, much to the delight of the states that have been waiting to get management of wolves back from the Fish and Wildlife Service for a long time. And then Subsequent to that, the Fish and Wildlife Service decision to delist was reversed by the courts on procedural grounds. Okay, but I mean it was challenged because people didn't. There were some stakeholders that were not happy with the outcome. And they used procedural grounds to get that reversed. And then subsequent to that, Congress stepped in and said, no, we in fact are going to delist the Northern Rocky Mountain population of the gray wolf. It will be delisted, okay? So they passed a law about this. And so that's pretty severe management turbulence, okay? So you've got management sort of taking place at the state and federal agency, but then you've got the courts and then Congress even stepping in to take a stand on these sorts of things. And you can bet that Congress didn't really give a stuff about the science or the processes that were either listing or dealing. They were doing it for political reasons, purely. Okay, so that's an example of a very high level of social indeterminism, where you've got these sorts of phenomena occurring where really political concerns are trumping any kind of management science or science-related or knowledge about what might be going on. Okay, so let's slide up, let's go back down the social indeterminate axis and slide up the natural indeterminate axis and talk about Laysan ducks. So Laysan ducks, not a whole lot of them left, a few hundred. Just until recently, they were only found on Coral Atoll in the Hawaiian archipelago, Laysan Island. Highest point above sea level, something like 6 meters above sea level, so they're a tiddly little island. Really high levels of, we don't know a lot about these birds, not as much as we know about mallards, for example. And moreover, we don't know anything about future sea level rise. We don't know anything. We know that it's likely to happen. But how fast and how much are, I would argue, still open questions by and large. And, and the thing is, on Laysan Island, it doesn't take a whole lot of sea level rise to really reduce the habitat. So they're sort of considering a whole range of options for this species. They've recently introduced a population to Midway Atoll. There were lots of discussions before they did this. They're creating, as we heard from other talks at the conference, about novel ecosystems, essentially creating a novel ecosystem on Midway by introducing these guys there. There's sort of disease issues of what will happen if they take a sizable chunk of the Laysan population away. Does that harm the Laysan population? So a lot of what we don't know about the natural dynamics of these things. About what the future outcomes will be if we translocate these species. However, there's almost no social indeterminism involved here. These two atolls are in the middle of the largest marine park in the world. Okay, so the only two groups of people that really either know or care much about these things are the National Park Service, who's responsible for managing the park, and the Fish and Wildlife Service, who's responsible for them because they're endangered. It's an endangered species, and so they all share values, and there's certainly going to be vigorous discussion amongst them about that, but they're unlikely to be challenged in the court system by stakeholders of one sort or another. Okay, they're not thinking about changing fishing regulations or any of this kind of stuff. Okay, so there's really low levels of social turbulence in this particular system. Okay, so now let's go across to the upper right-hand corner here, and this is the domain, I think, of what is called in many other circles, the wicked problem. High levels of natural indeterminism, so we don't know a lot about the dynamics of the states of nature, and high levels of social indeterminism. And the example that I want to use of this is the Pallid Sturgeon. So this is one of the three species that led to the biological opinion on the Missouri River. This is a Pallid Sturgeon, actually not on the Missouri, but on the Platte River. And this fish, is a big, long-lived fish, pretty clear now, after 20 more years of work, that they're by and large not reproducing. Okay. Why are they not reproducing, though, is really not something that we have a good handle on yet. There's a few hypotheses around. Maybe they need a high spring rise. That was sort of one of the original hypotheses. Maybe they just need a shot of warm water in the springtime. They wait until the water gets warm. Maybe they need 1,000 miles of uninterrupted river for the larvae to drift. We don't really know. I mean, and then there's other hypotheses about turbulence and all sorts of things. We don't know why, exactly why they're spawning but not recruiting into the population. At least we think they're spawning. But at the same time, there are experiments that could be done to resolve some of those uncertainties, and yet those experiments get at the very heart of things that people value about the Missouri River. In other words, having a spring rise of the magnitude that would test this hypothesis in a valid sort of way, increases flood risk and reduces the availability of water for navigation purposes. Okay, so it's strong opposition from groups that, in fact, do not want to see that happen, no matter what it does for the Pallid sturgeon. And they push back against this on a regular basis. So I think, sort of the brave hope for adaptive management as conceptualized by Buzz Halling and the people that follow Lance Gunderson and those folks, and even myself prior to my experiences on the Missouri River, was that we could make the Pallid sturgeon more like the mid-continental mallards. In other words, we could not only reduce natural indeterminism, but we could also reduce social indeterminism and make these processes much less contentious. And I think that the unfortunate reality is that the kinds of adaptive management processes that we have are not able to move these systems diagonally. Okay. That what happens is that if we do adaptive management and we get natural indeterminism down, we end up with situations that look like the Rocky Mountain gray wolf. So this is my rampant speculation. AM is not able to reduce social indeterminism, and failing to recognize that social indeterminism exists leads us to unrealistic expectations of the utility of science over on that right-hand side of the diagram.